demand and price to initiative the drivers, and then you need right demand and driver availability to set the price. So if you see, it's already all three are linked, interlinked in a sequential way. The next one we will see is the what is the problem here. So the request driven way, what is the problem? How to map transformation through the entire system? How do we debug here? So these are the problems we face here in this method. So to overcome this, we see a event driven. So publish and subscribe. So all the service published to a stream. Okay. So all three are connected through a stream. So all services subscribe to this stream to get info they needed. So you see compare the difference here and here. You see the difference here, right? So it's all three models are being integrated here. All are publishing the data to the stream, where you see the rider management, the driver management, the price optimization, all in turn they publish the data to the stream. So this event driven is more success actually. So the event driven, you can see the data flows through this system, can monitor the data transformation through the entire system. We can monitor this data flow through this entire stream actually. So barriers to stream processing. So what are the barriers here actually? Companies don't see the benefit of streaming. So that's the actual barrier. System not at scale, fast prediction working fine, online prediction would work better, but they don't need, but they don't know that actually. That's the problem actually. Companies don't see the benefits, actual benefits here. And then high initial investment on the infrastructure, mental shift, and then the Python incompatibility. So let's see a case study here with the Uber. So it's actually interesting case study. 2017. Let's see this actually, like where you see the flow chart, where this side where you have the incremental ingestion, where you see the transactional database RDBMS, and then the JSON blobs where you have the shared DBs, and then both are the change logs and both the change logs are connected to the Kafka. There it goes to the injection batches, and then it goes to your ETL process, and then it transforms the data, and then last it would be your highway spark, it could be anything, any notebooks there. So if you see the interesting thing here, from end to end, like from here to here, if it's a raw data, less than 30 minutes. If it is a modeled data, it's less than 1 hour. So that's the interesting thing you can see here in this case study from the Uber. And then you can see the data pipeline for online ML system. So this is a typical high level architect. So you can see the streaming data, and it has a control. The process is there, and the data is stored, and then it goes to the research. One side it goes to the research, another side the feature engineer. He will be checking this right or wrong. And the research starts from the data warehouse, and then it ingests the feature engineer it labeling, and then develop the ML model, and then my ML model has the interference again with the data feature engineer, and then the logs, and then there is a prediction, and then the application, and the end user is the application. So this is the data pipeline for online ML system. So let's do the creation of the training data sets in this last part. So data full of potential of biases. Like the data main problem is the full of potential of biases. So sampling, selection biases, under over representation of subgroups, human biases embedded in historical data, labeling biases, so etc. etc. So those things we'll see here now. Partition, then split it. This is the key thing. So the data sets need to be partitioned. Shuffle, then split it. shuffle, then split it. Test, valid, train. So this is the step. Test, valid, split. Shuffle, then split. You can see the sample like week by week, week 1, week 2, week 3, week 4, week 5, and then you see the phases. Aim for similar distribution of data types across. For example, split as 90% negative and 10% positive. So not representative in real world usage. This is not actually not going to be in it's not going to represent on the real world usage. This is the valid split. We discussed in the previous slide, remember, like valid, test, and split. You can see here like test, valid, train. But here you see better partition, right? Partition, that's what we're discussing, right? If you see here, the better partition is like this is the way, like week 1, week 2, week 3, week 4. Same week wise we're partitioning, but we did it in a different